All right, so now is the time, guys, right? It's like, okay, you showed some math stuff, super useful. You showed how to render in certain orders using a layer system, which is fantastic as well. But we need to make a game. We need to make Pong, and might as well actually start making Pong. All right, so here, we described entity, blah, blah, blah. If you watched that part of the video, showing how the render stuff worked, just know you only need scene, globals, all this stuff here. You don't need entity. You don't need this. Goodbye. We're actually going to keep the file. We're going to rewrite it. Because certain things should be objects, certain things should not be objects, and having a stack of inheritance so high like Unreal Engine where everything is an actor and blah, 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 that's a little much. And in the case of Pong, we have two styles of what we need. We need something to describe a paddle, and we need something to describe a ball, and we need a way to say, hey, I'm the player, and the other one is either player 2 or it's AI, it's a computer, right? So here I'm going to say we're going to make a paddle, and then we're going to make a ball. The one thing that these both have in common is they can be rendered to the screen. So we're going to include globals. And this is going to fetch our iRenderable system here. Notice they don't have to both, inherit from entity. They are technically different things. And they do share a few things in common. For example, they share a transform in a lot of ways. So in this transform component, I'm going to have a few things. There's going to be a vector 2, we're going to call this position. Vector 2, we're going to call this size. I'm also going to have a float for a radius, because the ball needs a radius and it's not quite size, and it's good to have it's good to have both, even if you don't use both in one class. So here, these things are both going to have a transform component. The main difference is in render here and in render in our other, one's going to draw the paddle and one's going to draw the ball. So here, if we have, for example, the ball, and I have to include our entity here, so ball, like so, and we're going to have like a draw circle, and I think there's like a draw circle V, which would be nice. Yeah, so this is going to take in a center, what our radius is, and our color. So in this case, our center is going to be our position, and then our radius, and then we need a color. I believe the color of Pong is like white ball, something like that. Be my guess. I would also say, you can decompartmentalize even further. You can make a color such and such. Not totally necessary, but also definitely okay if that's what you'd want to do. Again, this is meant to be an intermediate tutorial to kind of go a little bit further than shoving everything into a main file. We're kind of, utilizing a bit beyond that and describing a few things. We will come back to remove from scene. There's a reason I included algorithm for that. But anyway, back over here, paddle. We're going to have some definitions for as well. So we have render. And here we're going to draw a rectangle V. This is going to take in our position, our size, and then our color, which I believe is also white. Now our loop right now, I believe, is clearing the screen to white. So in this case, we will want a black screen. And in entity here, there's a couple things we want here. For this transform component, we could go ahead and also put direction here. I think that would be fine as well to include. Things are going to need to know that direction, that whole normalization stuff we had talked about earlier, and having like a update. These are going to be shared as well. And we talked about over here, we're like, this is drawing the things, but we also are going to want some type of manager to handle updating all of our entities as well in the game. You can go further and make more systems, use smart pointers. I'm going to keep this relatively simple because, again, it's still an intermediate tutorial. So we're going to do I wonder, the way I've been doing this, I think I'm going to just kind of go like this. And so this void update scene, it's going to be very similar to our draw scene here. The only difference is we're going to want to call update. Now, update does not currently exist, so we're going to come over here to a virtual void update. It's a pure virtual function. Control-Shift-I is what I'm doing to format these files here. And if we come back over to entity, virtual void update. And these updates are going to be very similar to each other. So for example, paddle update, it's going to return a void. The tcomps position, the x is going to have a speed. And that's going to be multiplied by the tcomps direction in the x. Similarly with the y here. Now this is kind of the other thing as well. Notice we have all these components. We're like, hey, they're shared, so let's shove it here. The question becomes, how much of that do we do? Can we put float speed here? Yeah, absolutely. It's an interesting conundrum, honestly, because the further you go in development, choices you make early on can affect development a lot. And these are already looking like extremely similar, right? Almost in the fact of like, well, shit, why are we doing this twice type of thing for some of this stuff? And that is kind of kind of a conundrum here, right? Because then we're going to also redefine update over here. Because of that, something that I said I wouldn't do, that I think I'm going to do, just because I can do, is we're going to do this as well. And I'm actually going to put these components here. I'm going to call this public, like so. Because this is, you know, the overall thing. And I am going to erase that stuff there. Come over here and do entity, like so. This is inherited member is not allowed. Well, let's try like this. So we have entity render file save. Yeah, that should be fine. We're going to grab these, and instead of, because it's going to be kind of weird in some cases, for update, we really don't care about redefining it, but we do want to override our draw. So for example, we know everything when it moves is going to have its position relatively follow the same thing. And in fact, too, we know that tcomp.direction is going to be normalized. So here, I just want to make sure that I'm including our math library. Like so. So we know all entities, they're going to be rendered, but the thing is, everyone's going to be rendered slightly different, so we don't have to really define it. We made like a stub. This is an empty stub here. In fact, I mean, we could say something like draw text here. And just kind of give a reminder. Because the purpose is not to have the entity itself drawn, but rather the a little bit down the chain here. 50 and then just like so. And that way, if entity is overall like, hey, yo, someone called it, this would appear. And then, you know, the person could go, oh, shit, right? Like, And you can put a reminder here as well. Be like, yo, base class, not for instantiation. Or however, you know. You should comment your code, but you should also know what your code is for and what it's doing. So in this case, this transform component, it's just kind of holding some of these variables for us in one bespoke place. Entity is in charge of updating, rendering, has a speed, so on and so forth. And paddle is just an entity. Ball is just an entity. Ball doesn't have to be a type of paddle. Paddle doesn't have to be a type of ball. This is is decent. It's maybe even a little bit too much, right? Because renderable is an entity, entity is a paddle. Or, well, vice versa. Paddle's an entity who's renderable. We shove that into scene type of stuff. It's it becomes kind of like a battle of perspective. And you make a lot of design choices when you're making a game engine. And when you're making a game like Pong, do you need any of this? Maybe if your Pong game's going to evolve, yeah, I would say so. But you could watch some of those tutorials where they shove everything in main and call it a day. That's it's not scalable. It's not even close to scalable. This is a lot better for scalability. All right. With that said, let's actually start doing something here. So what do I mean by that? Well, paddle here has a few rules it needs to follow. It's going to be as simple as a bool and is player. Not only do we need, hey, are we the player, but also having a fixed update. This is going to be paddle only here. So under like paddle, fixed update, doing the button presses. So for example, if is key down, and this is going to be that W, so on and so forth. So is key down W, S, A, and D. And this is going to be our direction guy. So from our component, we want our direction. It's going to be 0, 0. And then here, and there's one thing I hope someone has noticed before I noticed. This is Pong. We do not need, say it with me, X and Y. Bam. We don't need it. Unnecessary. Do we still need a direction then? Well, I mean, yeah, the ball can move diagonal. That type of stuff. It's going to have an initial direction, so on and so forth. So like, I don't know, its initial direction might be to the left. Something like that. Now we got now we just have to initialize a few things. So, for example here, this transform component would like to initialize the position, the size, direction, radius, that type of thing. I think for the simplicity of this, both paddles are going to be the same. So we could say, hey, I think my size for this paddle would be like 20 wide, 80 long, something like that. I'm going to just kind of go in here and check something. Yeah, overall. And then position is going to be position. What do I mean by that? So when I'm instantiating these paddles, I really don't know where I want it. And I know I'm going to need two of them. So I'm going to pass in a variable there. So when I'm creating this paddle, I put in a position I can have both. And then I want a Boolean called isPlayer. And here I'm going to say is, in this case, this isPlayer equals is player. Anytime you have a argument inside of a function, in this case the constructor, that is the same name, so if the argument's name is the same as a variable or a attribute, then you must use the this dot. It's kind of strange. It's fine. You could always name it something else if that bothers you. Because then you wouldn't need the is dot or the this dot, but that way also in here we could say, hey, if is player then we can listen to key presses. And then we have a ball, so on and so forth. And I know relatively that I'm going to say, hey, ball, your position is going to be the center of the screen. So screen width divided by 2 and screen height divided by 2. And your radius, so the T-comp's radius is going to be, I think, like 18 or so-ish, 20-ish, something like that. And for now, I'm going to just say, direction is 0, 0. And the last bit here is speed. So just going to make sure that I make a constructor for entity. And then for entity, I'm just going to have a basic speed here of 2. So what did we do? Well, we made a transform component and we placed that inside of an entity. Entity is a renderable. It has to describe the pure virtual functions, void update and void render. These are inside here. iRenderable, notice here, we're including globals. We're using iRenderable for scene. That's all scene cares about. It's like, hey, is that a renderable I see? And it has an update scene and it has a draw scene. It simply calls the update in the render for those things. And if we look over back at entity, paddle is an entity, but we take into position and we're checking, hey, are you the player? We also have this fixed update guy. We're overriding render. And then ball is very basic. We just have overriding render. Some of the definition here is drawing the ball, setting the position, the radius of the ball, drawing the paddle. And then here, notice is player with this fixed update. Well, how are we actually updating, getting this fixed update in, right? Because if we look at loop, loop knows about scene, scene knows how to draw, and scene knows how to do update scene. But fixed update, there's not really going to be a great way to get there. And in this case, I'm just going to leave fixed update out, just because I'm not doing fixed update at a different frame rate. It's not necessary, but what I'm going to do is just like we overrode the render, I'm going to override update as well. But we also want to call the base classes update. So here we're going to do paddle update and we want to call the update before it. So this is something that I'm going to have to remind myself on. So I'm going to say, hey, how to call base class function in C++. Notice here it goes base : print. So in our case, it would be entity update, like so. See, quick and painless. Was that an AI overview? Yeah, so what? I found what I was looking for quickly. And so we definitely, in our version of update, we're like, hey, I don't want to rewrite this. I want to utilize what was already wrote, but I want to add to it my fixed update. Like so. That way, if we are a player, it can listen to these keybinds and go accordingly. Notice how comp direction is 0, 0. It's going to happen if we're a player or if we're not a player. That's fine. That's absolutely fine. I'm going to come over here to loop, and here in it, I'm going to say, hey, paddle player is a new paddle. I'm going to have that to be a pointer. That's fine. And we need a position. So knowing that we're using the screen with screen height, I want to utilize that. So screen width is the right-hand side. And that's very long. But I want to be as close to the left-hand side as possible, you know, and in this case, like 20, you may be able to put. In the other side for its position, and I'm going to have to make sure I put brackets here and specify this is a vector 2. But for its height, I'm going to say, hey, it's going to be half its height, but it's also going to be like a little bit less than its size. So I'm going to say my size here. So, you know what? We're just going to do 80 for now. Having hard-coded numbers like that is not great. But at the same time, because player doesn't exist until the paddle exists type of thing, it's just kind of one of those things. I'm not trying to call from a variable that hasn't been created until after the fact. So, whoop-de-doo. It's okay. And then for this one, we're going to need a paddle. It's not a player. It's actually going to be like the screen width minus the minus 20-ish, something like that. And we're going to call this opponent. And then a ball pointer ball. And this didn't take anything, if I remember correctly. Yep. And so that should be fine. But we need to add this to our scene. So we're going to do scene.add scene player opponent ball. And then let's make clean, clear, and make, see what mistakes we've made here. Oh, well, there's a couple here. So inside of loop, we are calling fixed update here, which no longer exists. So that's this guy. And then scene.add to scene player. Didn't like that. We forgot, as in I forgot to put in what layer are we going to. So let's come back here. Layers, entity, like so. And then we're going to come back. And notice I can move my pedal. And just to kind of look at that again, we're a little bit off center with the ball. Its position, yes, is going to be using that center. I almost wonder too, our paddle should be slightly bigger. Yeah, that should be fine. Let's do like a $1.20. And run it again. Yeah, it's a little bit off, but I think it's a little bit off this case because of that hard-coded number we used here. And this is, again, one of the things about using hard-coded values. I think since we use subtract as well, that is the main issue because in computer graphics, the top left-hand side is the minus. And that's the other part. I think adding, get this, we need to go half as much. So, yeah, I don't know. Sometimes my brain goes a little bit faster. Curious. What if we just yeah, I was right the first time, but wrong the first time. We definitely, since it computer graphics are drawn from the upper left-hand side. So in this case, this rectangle is drawn right in that left-hand side there. And so, yeah, you see me struggle a little bit to get that centered. It's fine. It's not the end of the world. The one thing that I do want to show here is currently we can go out of bounds. That is definitely something you do not want.